Assalamu alaikum. My name is Mustaqin Ahmed Dafat. We're presenting the project of Control System on Laboratory, and our project title is Automated Waste Management System. The world is facing major garbage crisis, and we are now looking for smarter ways of overcoming garbage problem. The project design is a part of the implication that can be used to improve the waste management of a locality. The project resolves around whether the project will be able to meet the future needs of the users. In our project, we use an Arduino-based robotic vehicle with arm, which is capable of handling waste in different areas of Dhaka cities and sorting the waste for recycling purposes. There are two parts of our project. A waste lifting robotic car with arm is built to lift waste buckets from different places in the city. And the sorting system is built to keep the waste into two different buckets of metal and non-metal.
Hello, I am Mohammad Siratul Mustaqim Ifti. I will discuss about the first part of our project. It is the vehicle with the arm. So it will go to certain places and pick up dustbins and will keep them in its internal carrier. Then it will carry them to the dumping zone. So our whole system is controlled via app through Bluetooth module HC05. When we send command via app, the Bluetooth module pass the signal to the Arduino Mega. Then the Arduino Mega will act accordingly. It will activate, it will pass the signals to the motor drivers and the servos. Is when we slide change, please. If we look at the interface or application software, when we press the front command, then all of our wheels will rotate in the forward direction. When we press the back command, all of our wheels will rotate in the backward direction. If we press the right and left, then the left if we press the right command, our left wheels will be turned on and all the right wheels will be turned off. If we see at the there is a special command arm movement. If we press this command, there will be a premeditated move from the arm. When we will use it, if we place our vehicle in a certain in a specific place, then we will press this button and our arm will perform specific movement. Here we can see the internal circuit diagram of our system. Slide change, please. We can see that in our robotic arm we have used 6 motors to get the proper movement of this arm. We have used 6 motors. They are base, shoulder, elbow, hand, wrist 1 and wrist 2.
Hello, I'm Ahnaf Shahriar. We now look into the block diagram of the sorter. In this project, we are sorting the waste into 2 categories, which are metal and non-metal. For efficient sorting, we built a structure comprised of a cone-shaped cylinder with valve, conveyor belt, capacitive proximity sensor, and a rotating bin mechanism. We can see the setup in the left. Now, as the flowchart suggests, when waste are dumped into the cone, objects come in front of the sensor, one by one, while conveyor is running. A signal is sent to the microprocessor unit after a while. At the beginning, the valve attached to the cone structure is closed, but it will open after a certain time gap, which is fixed throughout the whole operation. When the valve is open, the waste will drop on the conveyor belt. At the same time, the signal which is sent to the Arduino processor will take a decision based on a value. If this value is less than 150, it senses a metal, otherwise it is a non-metal waste. Based on this value, Arduino processor sent another signal to the servo motor attached to the rotating bin structure that aligns the specific bin under the belt to collect the waste. Now, slide change, please. Okay, now we will briefly overview working principle of the capacitive proximity sensor. This sensor detects changes in the capacitance between sensing object and the sensor. When the object is brought nearby, mutual impedance between object and the sensor changes capacitance and thus sense the object. As it is cheap and available, we used this sensor in our project.
Hello, this is Safai Chaudhary Nirjan. We have built the robotic arm from scratch. We had ordered the 3D parts and here we can see the base of the arm. Here we can see the movement of the base. Initially only the base movement was ensured. The claw is not attached here. Then we have attached the claw and here we can see the base and the claw is moving, but the shoulder and the elbow is not moving. The grip is not that good initially. We have set the movement program by using Arduino, which is seen at the background. Then we have assembled the arm to the car and we can see the movement of the base and the claw, and the elbow is also moving here. The grip got much stronger than before. It can now hold up the garbage collector strongly and working pretty well. It is trying to put the garbage collector on the car. We have also built the car from the scratch. Here we see the building stages of the car. Firstly, we see the initial stage and then we see the intermediate stage where the inside part of the car is shown. Lastly, we have boxed up everything and our car is ready to go to do our desired task.
Here are most awaited monsters. Our Bluetooth control vehicle is moving from its base point to perform its job to clean up the garbage from the respective garbage collection point. Here, at first, it is moving towards its first garbage collection point at Dhanmondi area. We have seen when it is reached at that position, it is taking a break and it's trying to pick up the garbage bin. Here it is trying to pick up the garbage bin from the basement and it is trying to hold it in its back portion properly by using the robotic arm, and we have seen some garbage in the bin. Next, it is moving forward to its next garbage collection point at the new market area. We see here it is doing the same job as earlier performed in the Dhanmondi area. And here we have also seen some garbage in the bin. And here we see our interface of Bluetooth module app, which is used to control our both the vehicle and the arm. Here we see after collecting the both bins from the respective two zone, our control line is applied here to move it towards the garbage dumping zone. And it is moving smoothly to that position and it's parking here.
And here we can see how our bot is unloading the bins in the central dumping area. Now we will move on to the sorting part, which is very important in our project. Here is the structure of our sorter as we previously saw in our slides. The capacitive sensor is lying below the valve, which is our main processing unit. It can detect metal and hence sends a signal directly to Arduino. The valve controls the movement of garbages one at a time. The holder above contains all the garbages together. From the side view, we can see the conveyor belt and rotating beam. The rotating beam comprises of a non-metal beam and a metal beam, which is labeled in the picture. It rotates with the help of a servo motor. We can see the 360 view of the sorter along with the valve in the next video. After this, we will go on to the sorting procedure. The first one is metal, which is processed by the sensor and detected. The second one is also a metal. So the sensor detects again and it falls onto the beam. The next one is non-metal, and so the beam rotates 180 degrees. Now the non-metal garbage has fallen. The next one is metal, and the sensor rightfully detects the beam, detects the garbage, and it falls onto the beam.
Hello, I'm Panthu. While doing the project, we have faced some problems. Then we fixed it, that you can see on the screen. We found some problem while moving the shoulder of the armed vehicle. Then the claw couldn't move perfectly. Also, our low torque motor was unable to carry the weight perfectly. In the sorting section, capacitive sensor missed the object, and the sorting bin wasn't perfectly synchronized. For solving those problems, we have changed some things. For a short range, we fixed the shoulder movement. Then we have used a higher torque motor. Also, the sensor was mounted in a cone-shaped structure for solving the sorting problem. Then we think our project have some special features. Look, a megacity like Dhaka needs an automated system badly. Our binary sorting project will serve this purpose efficiently if we use it in a large scale. Also, for sorting and managing the metal and non-metal object and garbage, it can be used. We can use our project for this type of many purpose with a very low cost and budget. Also, this is user-friendly and easily movable. Overall, our next generation waste management should be like this.
Hello, I am Abhishek. At this point of the presentation, we must look at some of the limitations of our project that will give us inspiration for future improvement. First, it's binary sorting of the waste stages. In modern world, wastes are being sorted into categories like wet, organic, metal, plastic, etc. We could not incorporate these categories into our project. While dealing with the instability of the arm, we tried to fix it by limiting the shoulder movement, but we could not quite solve it. At times, the hand was a bit shaky, which created problems while lifting the bucket. We could not make the vehicle move sharply, as that would necessitate high-cost mechanism wheels. Although the capacitive proximity sensor performed very efficiently, we had to build a very complex design of the cone so that the object moved very close to the sensor, which might be a difficult issue in real world. Lastly, the servo motor mounted just below the sorter sometimes responds late to the proximity sensor signal, a problem which we could not solve. Such late response might create problems in collecting the garbages in either of the pods. Next, it's time to look into the future. Basically, we think that solving our aforementioned limitations will make the project a complete self-sustaining waste management system, like incorporating more than 2 categories, using proper controllers like PID in feedback control. Also, using off-mechanism wheels will make the vehicle a very smart one. Lastly, we think in an era of artificial intelligence, The object sorting process should be done using a proper deep learning algorithm. That's all. Thank you for listening to us patiently. Feel free to ask any questions.